Good afternoon everyone, my name is Oleg and today I would like to touch on a topic that might seem odd at first, but I promise you that it holds a lot of potential in it, and that is slime. Now, you may be wondering how on earth did I stumble upon such a peculiar idea? The answer is simple, Instagram Reels. While scrolling through Instagram, seeing all the cat videos and cooking tutorials, I stumbled upon a snippet about slime. I started reading about it, and it turned out to be much more interesting than I could have ever imagined. Contrary to their name, these fascinating organisms are actually not molds, but they rather belong to the kingdom of Protista. These are a group of mostly single-celled organisms, and the majority of them are amoeba and simple fungi. And now picture this. You're walking through a forest, and beneath the towering trees lies a hidden world teeming with life. Among all the decaying leaves and logs, slime molds quietly go about their business, playing vital roles in our ecosystem. Slime molds can be small, single-celled organisms, or massive multicellular structures visible to the unaided eye. They occur in a variety of sizes, forms, and colors, and even though they keep different appearance, they have one thing in common. They all love damp, organic matter-rich environments. Because of their durability and resilience, they can live in a variety of environments all over the globe. And they are vital, especially for the ecology, as they are essential for the breakdown processes. They consume the organic matter which is decomposing and then release back the vital nutrients back into the soil. Now, imagine a world without slime molds. A world where the fallen leaves accumulate endlessly and that nutrients remain locked away in the decaying matter. Indeed, slime molds may not always see the spotlight. However, they play vital roles in sustaining natural life on Earth. That's why I think the next time you're walking through a forest, you should appreciate their work. Now, we are going to be astounded as we explore the qualities, the habits, and the intelligence of slime molds. Even though they don't have brains or nervous systems, they change our perception of the word cognition. A fascinating example of slime mold intelligence is a set of studies conducted by Dr. Toshiyuki Nakagaki in 2007 in Japan. In this set of experiments, fragments of food were placed in different spots within an agar maze. And the events followed were just astounding. Even though slime molds are such simple creatures and such simple organisms, they exhibited abilities to navigate one of those mazes and they had key problem-solving abilities. When placed at the entrance of the maze, they extended their network of tendrils, accessing all the nutrients and all the food that was placed in the maze. And remarkably, later they were able to sort out the most efficient and the shortest routes within those mazes. What makes this even more remarkable is that slime molds don't have any central controlling system or any processes that control it from like the brain. And each individual cell of slime mold operates autonomously, and yet collectively they coordinate their movements to create a functioning and efficient organism. This decentralized form of intelligence is also known as the emergent behavior, and it has captivated scientists for many years as of right now. In addition to their navigational prowess, slime molds have demonstrated an ability to adapt in response to changing environmental conditions. In another set of experiments, researchers presented slime molds with obstacles such as barriers or unfavorable conditions, forcing them to find alternative routes to the food sources. And what happened was that the slime molds exhibited, once again, problem-solving abilities and quickly adapted their growth patterns to circumvent those obstacles and find new ways, new accesses to those food sources. In some cases, slime molds even exhibited something resembling memory. They recalled past events and quickly adapted their behavior accordingly. And these experiments only prove that even though slime molds don't have consciousness, as we defined it, they hint that there may be a deeper complexity within the natural world. So now, what can we take away from the intelligence of slime molds? Perhaps it's the power of decentralized decision-making and collective intelligence. In a world where centralized control often dominates, slime molds offer a different alternative, a model of coordination and collaboration that transcends individual limitations in order to create something greater and in order to combat new problems. Now, as far as the biomedical applications go of slime molds, They hold significant promise in various fields, from tissue engineering to drug delivery. The ability of slime mold to self-organize and create complex structures could offer insights into new approaches for creating organs and transplantable tissues. By harnessing the capabilities of slime molds to operate in mazes and find the quickest possible routes, scientists aim to create scaffolds that will be able to sustain the growth and differentiation of cells, of human cells, which will ultimately enable us to create transplantable tissues. Moreover, studies have demonstrated the feasibility of using slime mold inspired networks for guiding growth of neural cells, offering us the possibility of repairing damaged nerve tissue in cases such as neurodegenerative diseases or spinal cord injuries. However, slime molds found their way not only into medicine, their impact on the fields of computing and civil engineering is also profound. Inspired by slime mold's work, scientists were able to create many different algorithms and design principles that have revolutionized both fields. By mimicking the way slime molds find the most optimal routes, scientists were able to create many different bio-inspired algorithms known as SMA, slime mold algorithms. And they can efficiently route information through networks, optimize transportation systems, and even solve some problems with supply chains. For example, researchers have used those slime mold-inspired algorithms to help with the efficiency of supply chains, railroads, and roadways. And they did it by finding the most efficient routes for traffic flow and for resource distribution. All in all, these algorithms can help improve the efficiency, the resilience, and the sustainability of such complex systems, as mentioned a moment ago. And it can be done in a huge variety of domains. Moreover, scientists have used mold-inspired design principles to create self-healing concrete, which can heal cracks autonomously without the need of costly repairs or maintenance. Additionally, slime mold-inspired algorithms have been used to optimize the layout of urban infrastructure, such as subway systems. There was also another experiment where slime molds were used to rearrange the Tokyo subway system, and they did it much more efficiently than humans did. So, as we come to the conclusions of our exploration into the remarkable world of slime molds, we are left with a profound appreciation for how these are complex and how the complexity and ingenuity of these overlooked organisms is important. From their ecological significance to their surprising intelligence, slime molds challenge our very idea of what it means to be alive and offer valuable insight into many different fields. Whether navigating mazes, optimizing railroads, or subway systems, slime molds remind us that nature is full of surprises waiting to be discovered, and that by collaborating with nature and working with nature, we can unlock possibilities for innovation and progress.